The function f has domain 1 infinity and is defined by f of x equals 2x minus k, where k is a constant. Write down in terms of k the range of f. The function g has domain 0 infinity and is defined by gx equals 3x squared plus 4. Find the largest value of k that allows the function g of f to be formed. Given that g of f equals 2 equals 31, find the value of k. So let's have a look at this then. Right, one thing at a time then. F has domain 1 infinity, f of x equals to that. Write down the range. So if it's a linear function, which it is, so I'm just doing a little sketch in my mind's eye. Gradient 2 intercept minus k. So there's the sort of thing we're talking about here. That value would be minus k, wouldn't it? This would be f of x. So there's a little sketch in our mind's eye of the function. It has domain 1 infinity. So basically all of this stuff on the negative side for starters goes, and it needs to start from this point here at the value 1. So all of this goes, of course, and it's just this side of 1, isn't it? Just this part of the straight line. Okay, so it has domain 1 infinity. Write down the range of f then. So here, a range of f is, okay, so 1, because it's an increasing line, the smallest value of the range value would occur at 1, wouldn't it? So if we put 1 in here, we get 2 minus k. That's the smallest value it can have. And because that was a closed point, it touched 1, it touches the smallest value, doesn't it? And then it continues to increase. All the y values continue to increase as it goes forward on the domain. So it shoots off to infinity, doesn't it? So there's the range. G has domain 0 infinity, and g of x is equal to this. So I'm going to do a little sketch of g now. I've done f, so let's get rid of that. Now let's worry about g now. So it's a 3x squared plus 4. So that's a quadratic U-shaped curve, like so. And there's the value 4. But it's only defined on the positive side 0 to infinity from here forwards. So all of these part of the sketch is not to be included, is it? Okay, so there's our function then. Here it is here. So g has domain 0 to infinity, which we mentioned. G of x is equal to that. Find the largest k that allows g of f to be formed. So that value needs to be 4. So g of f at 0, g of f, so this is part B, g of f of x, which is equal to g of f of x. Now, domain, so the range must lie inside the domain of g, mustn't it? The range of f, these values, must lie inside the domain of g for it to be formed. The range of f is this, so this must sit inside 0 to infinity. So here, the range of f, which is this, must be a subset, it must sit inside of the domain of g. The range of f sits inside the domain of g. So that tells us then, provided that this is positive, greater than or equal to 0, we're okay. So 2 minus k needs to be greater than or equal to 0, i.e. move the k over k and read it from right to left is less than or equal to the value 2. So k is less than or equal to 2. Okay, so we've done that then. Given that g of f2 equals 31, find k. So part C now. So g of f of the value 2 is equal to g of f of 2, which is equal to, now, f of 2, so where's f of x? It's 2x minus k. So I'm going to write x for the moment and work out the composite function explicitly. So g of f of x here, g of f of x, that would be g of f of x, which is 2x minus k, if we remember. There it is there. So put that in here. And then g sends something to 3 times something squared plus 4, doesn't it? 3 times something squared plus 4. So it's 3 times this squared. Something is 2x minus k. 3 times something squared, was it plus 4? I think it was plus 4, wasn't it? Let's just check one final check on that. Yeah, 3 times something squared plus 4. There it is there. So if we put 2 back in now, so g of f of 2 is equal to 3 times 4 minus k. 2 2's are 4. 4 minus k squared plus 4. And that equals 31, isn't it? From the question. So now we just need to solve for k and find the value. So move the 4 over. 4 minus k squared is equal to 31 minus 4 is 27. Divide by 3 both sides, or move the 3 from times on one side to divide on the other. 27 over 3 is 9. Square root both sides then, so we get 4 minus k will equal plus or minus 3. And that then tells us that move the k over there and read from right to left. K is equal to 4, and then move the plus or minus over here, and it's minus or plus, isn't it? 3. There's still a plus or minus. So that tells us then that k can equal 4 minus 3 is 1, or k equals 4 plus 3 is 7. But we said from before that there's a condition on k. K needs to be less than or equal to 2, doesn't it? So k is equal to 1. This value is invalid.